Good morning. My name is Alex Lee, and I'm a PhD student at Clemson University. Thank you for attending this talk. The paper I'm going to be talking about today is titled Virtualized Speech Practice for the College Classroom and was authored by myself, Albert Costa, Alyssa Davis, Darren Linville, and Larry Hodges. This project was developed in conjunction with the Clemson University Communications Department. We had several goals when developing this project, the first being to develop an alternative practice method for practicing speeches for the COM 2500 course. This is our public speaking course at Clemson University. We also wanted to study the effectiveness of virtual reality practice using the performance of real-world speeches given after the practice session. We also wanted to allow students to practice in virtual reality before presenting in front of a real-world class. And as a byproduct, we wanted to help reduce the number of teaching assistants needed for the comm department's lab. There's a large amount of pre-existing work in the space of virtual reality for public speaking, going back to the mid-1990s. However, most of those studies focused on the clinical or laboratory environments and focused on diagnosing primarily phobia cases in terms of public speaking anxiety. There is much less work present of a typical college classroom environment, like the one the average student would experience as their primary method of instruction for public speaking. Our contribution fits into this area as we designed a system with the college student and environment they exist in mind, and designed our system to be independent of a clinical or laboratory environment. This means that for our system, we removed or minimized the need for calibration beyond initial setup steps. That way, the system could be managed by non-technical undergraduate teaching assistants employed by the Department of Communication. Our previous paper on this subject compared our simulation to participants using the standard practice method for Department of Communication, comparing primarily grades and apprehension measures between the conditions. In this paper, we're evaluating primarily how the quality of the practice in the virtual session affects that self-reported apprehension and grade, as well as if we can use the approximations of participant gaze to determine behaviors that are indicative of the quality of practice. We also measured behaviors in the VR simulation and looked for any potential patterns. So now I'm going to tell you a bit about the testing environment we designed our simulation to fit within. Public speaking is a general education requirement for all majors at Clemson University, and the simulation was based on a typical college classroom environment those students would experience, about 20 to 30 people per class, typically freshmen and sophomores, and in a small to medium-sized classroom. Students are normally required to practice their speeches in front of an undergraduate TA. Our simulation is in place of that and was put into a small isolated conference room which allows the student to practice on their own in total isolation. The system allowed the students to also scan in the note cards they're allowed to use on their speech in the real world so that they could use them in the simulation. The system was designed and documented as well to allow the non-technical undergraduate TAs to operate and manage the system properly with minimal intervention or calibrations needed. So now I'm going to tell you a bit about the system design. Our system was built in Unity 3D using Virtual Reality Toolkit on a VR-capable computer with an HTC Vive as the headset. The instructions for the participants were integrated within the simulation to allow the participant to be alone in the room while learning how to use and interact with the system. Each participant was also given a unique ID number to use when scanning in their note cards and when logging into the system. This allowed us to link the note cards and data collected with their practice run together while preserving the anonymity of the identity of the participant. The audience is a continuous digital video of a typical college classroom audience listening to a speech. Now I will go through the procedure that the participants would have encountered upon entering the study. So the students would show up and fill in basic information and informed consent, and the student would be given a participant ID number. The participant is then led to the room with the VR system where the TAs will help them scan in their note cards. At this point, the TA leaves the room and the participant would enter their ID number into the system associating their note cards with their session. The participant then puts on their headset. Once inside the simulation, the participant begins by going through basic control training, teaching them how to move around and interact with the simulation. Participants would then complete their practice talk, which we will go over more in a minute. And the participant, after completing the talk, completes a post-survey known as a scam survey that we'll get to in a minute. 69 students participated in this study with 38 female and 31 male, and all of the members were of several sections of the public speaking course taught by the same instructor. So here we have a video of a participant in the simulation. After the participant is logged in with their participant ID number, they would then be confronted with this training area, which teaches them that they can move their head around in the simulation and will be asked to locate 3 objects in the simulation. Upon completing locating those items, the participant would then be instructed to press the trigger and now would move to the second phase of training, teaching them how to interact with and cycle through the note cards located in the controller by using the touchpad controls. After completing cycling through it and getting comfortable, they're instructed to press the trigger again, entering a phase where they'll press the trigger to begin their talk, and the curtains will open to reveal the audience to them. Once the countdown timer finishes, they can begin speaking on their talk. They are now actively being monitored in terms of head and hand position and rotation, as well as tracking the length of time that the speech takes. And they can practice as long as they feel they wish. There will also be timer pop-ups on the screen that will let them know when they have hit certain time thresholds for how long the talk should be. They will also have the option to pause the talk by pressing the trigger, and to exit it, they can press the grip and trigger simultaneously to exit the talk, or press the trigger to return to the talk. The primary measures used consisted of the situational communication apprehension measure called SCAM survey. It's based on a Likert scale, with some example statements including I was apprehensive and I felt peaceful. Students also received a grade based on their real-world speech completed 1 to 4 weeks later. These grades were given by the same instructor based on a rubric. The rubric was based on the NCAA's 8 public speaking competencies. We also tracked the student's head and hand position and rotation every 1/10 of a second to reconstruct the participant's behavior and gaze patterns within the simulation. The gaze reconstruction was an approximation based on raycasting from the center of field of view of the headset. We chose this method as it removed the need for complex calibrated eye tracking resources that would require a participant-by-participant calibration as typical in most lab studies, and we also believe this to be a decent approximation of what a participant is looking at, since it was found in the paper by Murphy et al. That participants' gaze rarely deviates from the field of view of more than 30 degrees without resulting in the participant turning their head in VR. We also defined several zones to approximate where participants were looking, allowing us to determine whether the participant was looking at the audience, the middle of the room, above the audience's head, or at their note cards. So we had several research questions we posed. Hypothesis 1 was the amount of time students spend in the VR practicing their speech will affect their grades on the speech. Hypothesis 2 was students who looked at their audience during practice will get higher grades. And hypothesis 3 is that more apprehensive students will spend less time looking at the virtual audience. So now we get to the data and results. So for hypothesis 1, to restate it, the amount of time students spend in VR practicing their speech will affect their grades on the speech. We found that students who spent less than 160 seconds in front of the virtual audience had a test grade that was significantly lower than the grades of students who logged 320 seconds or more, and this division was based on 320 seconds being the upper threshold of an acceptable speech and 160 seconds being below the minimum for passing the speech in the class. The middle group, however, was not significant in terms of either group. So we can partially confirm hypothesis 1 in that students who were in front of the virtual audience long enough to practice a complete speech had higher grades than students who spent little time in front of the audience to practice. To restate hypothesis 2, students who looked at their audience during practice will get higher grades. We did 2 sample t-tests and found that students who spent at least 82% of their time in the practice test looking at the audience or the note cards had significantly higher grades. We confirmed that more time looking at the virtual audience during the practice had a positive effect on grades. To reiterate hypothesis 3, more apprehensive students will spend less time looking at the virtual audience. We performed a regression analysis of the percentage of the time the subject was looking at the audience against the SCAM score. We found evidence of a correlation with a p-value of less than 0.1. With this particular observation, we found a slight negative coefficient highlighted on the chart here. We found evidence to support the claim of hypothesis 3. So in conclusion, what did we learn? Well, we learned our system was a successful replacement/alternative for the traditional practice methods used by the Clemson Department of Communication. It was also able to successfully operate outside of the traditional research or clinical laboratory environment. Students were also able to practice successfully within the simulation, with the exception of one student who had minor system issues and had to have their appointment rescheduled. However, the issues were quickly corrected, and the student was able to successfully complete their talk on the second attempt. Our system was also capable of running with minimal to no technical assistance or calibrations needed beyond initial setup. We were able to calibrate the system and set it up the first time, and then after that had almost no incidents other than the one mentioned above reported by the undergraduate teaching assistants in the Department of Communication. And using our documentation, they were able to successfully complete the study. We were also able to measure and define certain qualitative aspects of the simulation, primarily focused on the gaze approximation system, which allowed us to determine approximately what participants were looking at and observe certain behaviors and patterns based on that correlating with the apprehension measure in the post-survey, as well as monitor how long they spent practicing and comparing that to how they performed in the real world. So with that, thank you, and are there any questions?